Hello everyone, I'm Jiazhou from Monash University, and today I'll be presenting a project that I've been working on in collaboration with Arnaud Prouzeau, Barrett and Tim Dwyer with the title Effects of Display Layout on Spatial Memory for Immersive Environments. In immersive systems for data visualization, it is common to position data displays in a wraparound configuration. It is a fairly logical way to utilize the display capability. By arranging visuals to surround the user, as in modern Cave 2 environments, users can simply rotate to access the full display space. Such rotational navigation may be less physically demanding than walking involved in a traditional flat layout to change one's viewpoint. Recent studies have also reported the tendency to position visuals in a circular arrangement. However, this user behavior may be explained by an unwillingness to walk in a virtual environment. This might be because of the tethered headset or unfamiliarity with the physical navigation in VR. So far, there have been no clear guidelines for creators of immersive visualization systems on this rather fundamental question of how to lay out displays in immersive visualization spaces. In other words, wraparound displays are an attractive design choice, but are they actually a good choice for immersive data displays? To answer this question, we present two user studies to test the effects of different display layouts, flat versus full circle and flat versus semicircle, by investigating the user's ability to recall card patterns within the layout for a straightforward visuo-spatial memory task. We hope clear findings in this research can lead to more concrete design guidelines for immersive view management. Our initial study focused on examining the performance of a task that requires spatial memory with a comparison of flat and full circle layouts, while we are also interested in studying partial wraparound layouts. Early pilot testing with a visual-spatial memory task led us towards a minimum design with two conditions per participant to limit their exposure to VR. Thus, we first investigate our primary research question with these two extreme layouts. In a visual-spatial memory task from related work, we expect the flat layout provides some advantages over the full circle one. On the one hand, participants can take a step back to get an overview of the flat wall, which is impossible in a full circle layout. On the other hand, the flat layout also provides implicit landmarks at its edges and corners. Thus, to evaluate the impact of these advantages on participants' performance, we also include another factor called visual modifier. The visual modifier factor shown on the left has three levels to address both advantages of the flat layout. We first have a regular condition as a baseline condition. Then, we design a restricted field of view condition to mitigate the effect of overviewability. Participants can only see the closest three columns for both layouts. And lastly, we designed a landmark condition where different landmark arrangements are created on the grid to indicate the front, sides, and back. As we mentioned earlier, we want to limit participants' exposure to VR and rationale repetitions. So we designed this study as a mixed design with the layout as a within subjects factor and the visual modifier as a between subjects factor. In total, we recruited 36 gender-balanced participants. Each visual modifier group had 12 participants. We used the room scale VR in a 10 meter x 5 meter empty room, where users must use physical locomotion to navigate. Participants must learn and recall a pattern of 5 cards within a 12x3 grid. We created a fixed sequence of patterns by generating them in a constrained random manner. There are 3 constraints for this generation. First, cards cannot be adjacent. Second, at least one card is included on each row to balance the pattern vertically. And third, at least 2 cards are included on each side to balance the pattern horizontally. Each participant will attempt 20 trials for both layouts, including 2 training trials at the beginning for each layout. The order of the layout is alternating to mitigate the learning effects. Each trial is divided into 5 phases. In the start phase, participants are required to stand at the starting position facing forward. Once in position, participants trigger the learning phase by pressing a button on the controller. Participants are given 15 seconds to tap each white card with the controller during the learning phase. Since short-term memory decays around 15 seconds, we include a distractor phase which lasts at least 15 seconds to isolate the spatial memory from the short-term memory. Then, in the recall phase, participants are asked to recreate the pattern shown in the learning phase by tapping on an empty layout. There is no time limit for this phase. In the end, we show the result to participants. Our results clearly show that participants are able to recall room-scale patterns of cars more accurately with a flat than a full-circle display layout in all visual modifier conditions. However, adding visual modifier to the layouts does not significantly improve performance, which means that the overview and implicit landmarks provided by the flat layout are not the main reason for the difference in performance between the 2 layouts. The tracking data of the physical walking and head rotation shows that the flat layout requires more walking, while the full circle layout requires more head rotation. From the post-experimental NASA task load index results, participants reported that flat layouts require less mental effort and cause less frustration. For the overall preference, participants rated the flat layout as their favorite one. In summary, our first study points to the conclusion that the main factor that impacts spatial memory is their orientation due to the rotational movement using the full circle layout. These findings suggest that, with tasks that depend on user spatial memory of the layout, full circle wraparound layouts should be used with caution in immersive environments. The first user study focuses on the 2 extremes of the curvature spectrum. However, recent work shows that participants also prefer the semicircle display layout, which provides less rotation. We then ran a second study to test the effect on the spatial memory between the flat and semicircle display layout with the same tasks and procedures as the first study. We recruited 12 gender-balanced participants and used a within-subjects design with these 2 layout types. The results don't show a significant difference in the accuracy between the flat and semicircle layout. However, we can see a significant difference in the physical demands, such as the walking and head rotation data. From the data, the semicircle layout requires less head rotation than the full circle layout and less walking than the flat layout, which seems like a compromise between the 2 extremes. Regarding user preference, more than 3/4 of the participants prefer the semicircle layout in the post-study questionnaire. In summary, with tasks that depend on user spatial memory of the layout, flat layouts and semicircle layouts are more performant than full circle layouts. The semicircle layouts provide a good compromise between the other 2 layouts and are most preferred by participants. The full wraparound layouts and the rotation required to navigate them are disorienting to users and should be used with caution for immersive information presentation. This finding is contrary to use patterns we see emerging in the literature. So, we hope this paper will influence future system implementers to be aware of this limitation and further research to find nuance. There is a future opportunity to more thoroughly explore the curvature design space. For instance, vertical curvature and a spherical layout. it would also be interesting to study the impact of interaction techniques that avoid walking, like VR teleportation or virtual panning of the shelf. However, this may also be less natural, disorienting, and may impede any kinesthetic memory effect. Finally, we feel it is important to explore the connection between spatial memory and analytic tasks in information visualization. While immersive environments provide users with more space to think than traditional displays, designers must be able to understand the implications of such environments on spatial understanding when creating tools to facilitate user understanding. That's it for my presentation. Thank you for listening.